In today's video, we are going to talk about using the RTL-SDR USB software-defined radio device along with an external antenna to potentially start trying to reverse engineer these wireless key fobs for an Evolution golf cart. This is kind of a good engineering practice. What you have here is similar to what's going on in an average key fob for a car, and I wanted to see if I could potentially make a replacement fob myself. These can be kind of hard to find and rather expensive, so I wanted to see, hey, if this is really just 433 megahertz frequencies, maybe it doesn't even use that advanced of a technology, maybe we can find a way to reverse engineer it and make our own at home. So the first thing you're going to need to do is go on Amazon and grab one of these software-defined radios. Now, they typically recommend using this software called AirSpy SDR, and it pops up right away. Down in the settings, you would choose the USB device here. The other thing you can do is define your frequency that you want to listen for. So for us, we know it's around 434 megahertz. So I've kind of specified that here, and that's defined the zone that we are listening in. The other thing you can do is don't forget that you can zoom in, because some of these may look really small at the beginning. So you can kind of zoom as you go and you figure out your wavelengths. What I realized is if you right click on here, this little yellow line will kind of define your high points. You right click, it goes away, right click, it defines it. So what I'm gonna do is I'm gonna hit the button on one of my remotes here, and you can see button down, button up, button down, button up. So you can kind of see there's a little wavelength there. With this is one of my remotes. I'm gonna grab the other remote, button down, button up, kind of in a different spot, you see. So the two remotes seem to have a consistent pattern for down and when you lift. So I believe it's a button down and a button up, but yet each remote has a slightly different code that it is putting out. Seems like the code is consistent but different between the two remotes. Now, the next thing I wanted to do was a test to see, is the code that when we hit the start button on the cart, what ends up happening is when you hit the start button on the cart, it sends a message up to the module. The module will send out a broadcast on a different frequency to the keys, looking for an acknowledgement back, looking for them to return an acknowledgement. And if they do, it will connect the power to the rest of the cart and everything will power up. So what I've done here is I put one of the key fobs within range of the antenna. We are listening on the same 433 megahertz, and I am going to hit the start button and we're going to watch what happens. And like that, you see a little spike right over here. So we were able to see that acknowledgement be returned from the key right there. So that is the acknowledgement. That acknowledgement is different than the button push. So if I hit the button, we can see where that is in the spectrum versus the cart acknowledgement. What I'm going to do now is I'm going to turn the cart off again. So we're going to turn the cart off. I'm going to do the exact same thing. So cart's booting up. And like that, you can see it's almost identical in that exact same small area. So I don't believe that these keys have a rolling code. It looks like it's very consistent. The same response is being sent back. So what I'm going to do now is I've swapped the key out for my other key, and I'm going to do the exact same test. So let me move the mouse, and we are going to turn the cart off, and we're going to turn it on again, and we will watch. And you see there, so the other key is, it's in a slightly different spot. So we'll turn it off. So a slightly different frequency is where the other key is sending its acknowledgement. Let's turn it on and see like that. Very identical acknowledgements each time from the two different keys, just on slightly different frequencies. So that has me thinking that the keys are probably rather simple. They likely do not do a rolling code where the ignition is giving it a new code or a new sequence number each time. It seems like it's a relatively simple request and acknowledgement back to the ignition box. So with that said, that's all of the progress I've made so far, is really just being able to understand, it looks like, the communication behavior and the patterns between the ignition box and the key fobs. It is my goal to one day be able to build our own using an Arduino or an ESP32 to emulate and listen to the request and respond back, essentially cloning one of these existing keys. So subscribe if you want to see that, and if I get to that point, I'll share it with everyone. I'm new to attempting to work with radio frequencies and things like that, but it's been interesting to learn more about. So if you have a lot of experience with radio frequencies and you might have an idea what's going on inside of these, let me know in the comments below what I should do next. I cannot broadcast with this USB device. This is a listening device only. So we can't record the wavelengths and replay it using this device here. It is just for listening. So generally what I'm going to do next is get some Arduino and ESP32 parts with the ability to listen on RF and broadcast on RF. And we will see if we can find any way to duplicate what's going on here. So thanks for watching. And if you have any idea of what's going on inside these Evolution Cart key fobs, you've been involved with programming them or setting up new ones, also let me know. Cheers.